it's it's an interesting graveyard. There's some interesting people who are buried there, so should be interesting. Okay, so we are live on YouTube. Probably were a little bit before. There we are. We've got our. Let me just pull up the 466 discussion so I know what's happening. Like I said, this is being recorded, so please, if you don't want to be recorded, you can watch on YouTube live, and that's okay. So we're getting towards the crunch end of semester, and I need to talk about a few things. I have gone through. Everybody has done the midterm, so that's good, and maybe I should spend some time giving generic feedback on the midterm, so I might do that this morning as well. What I want to do today is start winding up the labs that I want you to do, and start talking about what your project means. And that's going to be up to each individual team, each lab team, to figure out what they want to do. The two things that I would like to see possibly in each project, one of them is to generate VGA output so that you can see something that's happening, but that will depend on people having a monitor and a VGA cable, so that may not be possible. The other thing that is possible is to have a look at using the remote control, and I'm just going to figure out where my remote control got to. I think that's it. I think it's in there from memory. Maybe not. Should be in there. There it is. Right, so all of your boards came with, let me just go, where's Streamlabs? There we go. And let's go to the other windows so I can make it a bit bigger. Right, there's a bigger me. And the idea is that you've got, everybody should have one of those-ish, right? It's a remote control. That should allow you to talk to the board. And I forgot to change logos, so let's change logos. There we go. On the board itself, let me see if I can show you on the board itself. Where are we? I think that's there, and I think I can pull that up. There we go. So there's the board itself, and I've got it lots of blinking lights. But beside the blinking lights, that device there, that little silver thing, that is an infrared receiver, and that takes the output from the remote control, and we can decode it. Okay, so that's that would be something good to do. But I do want something a little bit more complicated than some of the things we've been doing to date. Oh, sorry, Adonica, I just saw the question there. I think I am. Is anybody else having issues seeing the screen?
No, I see you.
Yeah, okay. So if if Discord's having problems, maybe let me just grab the let me go through the I can't see the YouTube link coming in. Normally it emails me saying that it's gone. Anyway, I'll do that later. There we go, we got it. So there's getting a shareable link, and I'll post that in the links part of 466. So there's today's lecture, in case that helps. Okay, sorry about that. Let's go back here. So what I want to do in lab 7 is an up-down counter, and let me just pull up lab 7. Okay, lab 7 is a group assignment, and I've given you the entity definition, and you have to fill in the architecture definition for an up-down counter. And one thing I would particularly like to do is for you to see if you can get the clock connecting to your up-down counter to go to at 10 Hertz or lower. I apologise for my, let's just make that a bit bigger maybe, that's a bit easier to read. I apologise for last week's effort. I didn't manage to do very well in showing you the LPM counter from the library in Quartus, and the issue turned out to be that Quartus had got into some funny state, so that it wasn't letting me put in pins, it wasn't letting me do anything sensible, and just restarting Quartus was, I probably should have thought of that myself, but anyway, it's I did put together a video of how to get it to run, how to use an up-down counter, and that I actually played with it that a bit more, and a bit hard to see the I don't have a very good portable webcam, but you can see there's all I hope you can see that all 4 LEDs are actually blinking. And what I did, rather in the example I did in the video, I made a divide by 50 million counter, so a modulo 50 million counter, and I just, in the video, I just took out pin 25, I think it was 25 down to pin 0, so it was the 26th pin, the most significant bit pin, and I pulled that out and I connected it to the LED on the left hand end there. So that LED is now blinking at a 1 Hertz rate. But then after the video I added 3 more pins, pulling out pins bits 24, 23 and 22. So the second LED from the left hand end is now blinking at a 2 Hertz rate. The third LED is now blinking at a 4 Hertz rate, and the fourth LED is blinking at an 8 Hertz rate, which is kind of cute. I don't know about you, but I grew up in an era when you were supposed to have blinking lights on a computer, and that it always makes me think about a real computer instead of what we use these days. I know that's a bit silly, but anyway. So the aim with Lab 7 is to build an up-down counter. Now, what you could do with Lab 7 is you could just build yourself an up-down counter, right? And that should be pretty easy. Or you could use the LPM counter thing that I used for the division. And this time, instead of cutting out everything like I did, you could cut down most things, but keep the up-down input, which I believe is available on that library component. Okay, so I suggest you have a look at that. Now, where are we on that one? And then the Lab 8, the last programmed app that I want, lab that I want you to do, is a baseball scorekeeper, and I'm going to talk a little bit more about that. I hope I don't have to explain too much about the up-down counter. I will if you want me to, but the baseball scorekeeper is a little harder. It's harder for a lot of reasons. One reason that I found out last time I taught digital is that some students, and there goes my dog, that's because there's another dog walking down the road, of course. Some students don't follow baseball and don't understand any of the scoring, or at least the counting that I'm asking for. So I'm going to explain a little bit about that. And as someone who is only relatively new to baseball, I'm perfectly okay with anyone in the audience correcting me on anything I say. I must say I am really missing going to the Yard Goats this year. I don't follow any particular Major League Baseball team. The first Major League Baseball team, baseball game I ever got to was a game between the Nationals and the Phillies in Washington D.C. and that was great. If you ever get to D.C. and can get to a game at I've forgotten what Nationals Park is called, but it was really good. It was cheap. We were way up high. We weren't, right. It wasn't a particularly good seats, but we could see everything. It was a really good game. But that's just because that was my first Major League Baseball game. I have a slight soft spot for the Nationals, but other than that, it's a bit of a fraud thing, particularly around where we live. Some people really love the Yankees, and some people really love the Red Sox, and ne'er the twain shall meet, right? So this is stuff we did a few weeks ago. This is stuff also we did a couple of weeks ago. And last week I tried to look at counters in a bit more detail, but that wasn't as successful as I wanted it to be. If you haven't looked at the video, I think I posted the video in the links. Yeah, there it is. So there's the third last link has the video of me going through how to use one of the LPM counters. So have a look at that if you want to. That might help. But before we get into anything, I just wanted to go back and look at where we had to get to, right? We're running down towards the end of semester now, or we should be. And let me just So let's have a look at the academic calendar. Right, and finals are from the 9th to the 15th, and I've just started putting together the final for this course. But once we've finished the 8 labs, we'll be done with the laboratories. That'll be worth 30% of your overall grade. We've done the midterm. That'll be worth 10%. Remember I said that think of the midterm as a practice. So what that means is I'm going to put into Blackboard a couple of calculated columns, right? I'm going to put in, I've already put in the midterm, I've just added the final column, and I'm going to add one which is the maximum of the midterm plus final and the final, right? So it'll take the maximum of those two values, and that is going to be worth well, it's actually going to be, what's it going to be? It's going to be 25% of the midterm plus 75% of the final, and that is going to be worth a total of 40%. What that'll mean, right, that'll be the 10% plus the 30%. What that'll mean is if you did poorly on the midterm, it won't count. If you do better on the final than on the midterm. And the final, I'm going to run it in precisely the same way as I ran the midterm, a couple of weeks out, so probably just after Thanksgiving. I'll release the paper, and you should be able to see that around a week, maybe 2 weeks before the final. I'll open up some slots for you to book your final exam, and we'll do the final as an oral exam again. There will also be a written component, as there was this time, but again, you'll know most of what I'm going to ask you. I may add some additional questions, as you all probably found out for the midterm. I am likely to ask follow-up questions if I don't quite get the answer I was looking for, or if I need more information. But I'm hoping everybody was reasonably happy with how the midterm was conducted. Actually, on that, sometime towards the end of semester, I will the Blackboard will start annoying you for feedback about this course. So please please have a look at that feedback and give that feedback. Probably a bad thing to say, I don't tend to look at the numerical things unless there's something really out of whack one way or the other. I do value the the free form text, I find I get more specific constructive feedback from students on what can be done better or what I can do more of in that written feedback. So please, or that free form feedback. So please, when the time comes, and I'll give you time during class to do that, please give whatever feedback you can. I was lucky enough last week, Fairfield, as you probably know, I teach at Fairfield as well as Central Connecticut, and Fairfield has a peer review system or a peer feedback system where they pair people up who want comments from other professors about their teaching. And I was lucky enough to get one of the other professors to sit in on one of my Fairfield classes during the week. And they said some nice things about what I did, but even better, they gave me some constructive feedback on what I can improve upon or do differently, and that was quite good. Haven't quite digested all of it yet, but it was very, very useful feedback. So does anybody have any questions on how I'm going to do the grade?
I'm curious about the game, because I know the game was optional, so how would that 10% be spread out if you don't complete the game?
Okay, so that's a good question. I should have addressed that. Basically, I think what I will do is just if you don't complete the game, and I would like you to complete the game. I think it's a fun game, at least from a from a digital logic viewpoint. If you don't complete the game, then I think what I'm going to do, so that means that there's only 90% left. I think what that means is I multiply all of these percentages by 100 on 90 to scale them all up. But I am open to other suggested ways of doing it. Does that answer the question?
Yep, thank you.
You're welcome. And I will address this in more detail closer to the closer to the end of semester. But if the game doesn't happen, then as I said, I'll just scale those up. There are, I just realised, 3 people who haven't got game keys. If you are one of them and want me to get you a game key, let me know. I will get you a game key. I had forgotten about that, so I will. In fact, I'll follow up with you directly. I thought I only had 24 students in the class, so I only asked for 24 game keys. And on the other hand, if you haven't used your game key and you are not going to use your game key, let me know. Only if you haven't used your game key. If you have, then it's already gone. But if you haven't used your game key, please let me know, and I will see if one of the 3 students who didn't get a game key is interested in using it. Okay. Any other questions about where we are and what we need to do? Okay. Just pull that up there. There we go. So I hope everybody's had enough of a chance to tackle Lab 6. In fact, I just forgot something I need to do. Okay, sorry about that. So I don't have too much more to talk about with VHDL. I think I've covered. Let's just have a quick flip through the notes and see if there's anything that stands out. Right, so there's the list of things. I gave a bit of history. I've talked about systems and signals. I've talked about entities, architectures, and packages. More recently, I've talked about data types. I don't think I've talked too much specifically about operators, although we have implicitly used lots of operators, so maybe I should talk about that. There's the difference between structural and behavioral design, right? One of them is the using the multi-sim approach, which is allowed for in Quartus, where I can put in devices in a logic circuit, and the other way is by effectively programming it. Okay. And then the other thing is test benches, which I hope you've had some experience with now. And let's just see if we can find the operators section. Right. Just a reminder that sometimes you get devices like this, particularly on a board like we have, where there are a lot of what they call general purpose I/O pins. A general purpose I/O pin means that it can be used for input or for output, and it needs to have some sort of a switch like this on each of them to be able to do that. Right? You can't use a pin both as an output and as an input. It needs to change mode. And right, we've talked about this. Most of what we're doing is sort of in this range. We certainly don't go down into the KVL, KCL, physical device, differential equation stuff. We maybe go up into algorithms depending on exactly what we're doing, but we haven't really in our lectures. That's pretty much what we've done. Let's see if we can find those operators, because there was a nice list of operators there. We talked about entity, we talked about architecture. Right, entity is the definition of the ins and outs of the device, and the architecture is the actual implementation. There's some packages, and here's some data types. Single bit is a scalar, a bus is called a vector. We've used signals. Oh, we did talk about those data types, right? And bit and string. One thing we didn't talk too much about is you can actually build user-defined enumerated types. So you can do something like that, red, yellow, green, if that's what you fancy. And I don't know why that keeps hanging around. Wish I could figure that out. Okay, so here's some operators, logical operators: not, and, NAND, or, nor, XOR, XNOR, right? Exclusive OR and exclusive NOR. And then you may have used the addition and subtraction operators in the recent lab 6, I think, but we probably haven't used multiplication, division, modulus, remainder, absolute value, or exponentiation.
What's the difference between modulus and remainder?
Okay, so modulus ooh. That's a good question. So let me, where's my eraser? Oh, no. Let's just get rid of that. So 10 modulo 2, right, is we want to, modulo 2 means we can either have a 0 or a 1, and we just count up however many times, and in this case that's going to be 0, right, because I can subtract 2 5 times and I end up with 0. And I don't know what remainder. It's a good question. So 10 remainder, and I don't know what's happening with my computer. Sometimes it just lags the writing. I suspect it's that.
OneNote.
It's 1, is it?
It's OneNote.
It's
I
OneNote.
really like it, but like sometimes it lags out.
Oh really? That it might be because of the syncing, but yeah, it's only started happening in the last week, so
I don't know. Sometimes when I write on OneNote a lot and I scroll up and down, it just freaks out.
Yeah, that's a bit bizarre. So let's just have a quick look. I actually don't know what the there we go. There's a Stack Overflow question, right? So there's right. So it looks like there's no difference there. But then when you use a negative value, the modulo operator gives the residue for a division and rounds down. The remainder operator gives the remainder of the regular integer division and rounds towards 0. Okay? So that's a really good question. I did not know that. So let me just put that link in the... I'm finding myself wanting to say in the show notes, because one of the podcasts I listen to talks about that. So I just put that in the links chat. So does that answer the question? Right? That's a really...
It does.
That's one
I'm
of...
just still a little lost.
So what are you lost about?
So like they both round down. So
No, it depends on what you mean by down. One of them rounds down. So if you've got a negative number, it'll round even more negative. One of them rounds towards 0. So if you've got a negative number, it'll round up.
Okay.
Okay, that's the key difference. That in fact, let me see if I can take that. And I don't have my plug-in. I'll just put it in there. But I'll try and make that available from my OneNote later. I've been very lax in doing all of my things I need to do, so hopefully. Okay, so in this case, it is that the difference is going to be when there are negative numbers involved. And let's just see if we can figure out what happens, right? 10, well, let's say negative 10 modulo 2. I think that's going to give me the same answer though. Right, it's only going to change when the left-hand side operand and the right-hand side operand have different signs, I think. Right, so 9 modulo minus 5 is minus 1 because it's rounding down. Nine remainder minus 5 is going to be 4 because it's rounding towards 0. And if it went to minus 1, it'd be going past 0. Minus 9 mod 5, it's getting in the right range, whereas minus 9 remainder 5, it gets close enough with the minus 4.
How is it getting 4?
It's getting minus 4. Okay, so let's just take that. Let me just take a screenshot of that. And let's go back to OneNote. Ooh, funky. And where's my screenshots? There somewhere. There they are. Oops. And let's take it away from the, that might have to do. So, it's gone away now, that's okay. So modulo 5, right? So that means, I think, that we're looking for an answer between 0 and 4. Okay, so let's just check the modulo ones. So 9 modulo 5 is 4. That sort of makes sense because we subtract 5 from 9 once, we get a 4. Now 9 modulo minus 5, that's going to be looking the other way, right? So for the minus 5, we're going to be looking for an answer between 0 and -4. Okay, so that's the modulo range. So that's, I think that one makes sense. I think that one makes sense. Let's just go here, -9 modulo 5, right? We need to, it's a modulo 5, so this is the modulo 5 version, this is the modulo -5 version. So the modulo 5, we need to end up in the range 0 to 4, so that's correct. And then the modulo -5 for -9, again we need to end up in the -4 to 0 range, so that one's correct. So I think the modulo one makes sense. Now let's see what happens with the remainder one. So remainder, and let's just see if we can go back to the statement, right? The remainder operator gives the remainder of a regular integer division that rounds towards 0. So it's truncated division. So in this case, so we've got 9 divided by 5, and that's going to give us a 1. So the remainder, it's really badly lagging, the remainder is going to be 9 minus 5 times 1, right? Which is equal to 4. So I think that one makes sense. Now the next one, 9 remainder minus 5. So again we've got 9 divided by -5. And what's that going to be? That's going to be -1, right? Because we've got the negative there. So then the remainder is going to be equal to 9 minus -5 times -1. And again, that's going to be 4. Okay, so there's three negatives there, right? There's the minus to find the remainder. There's the minus on the -5, which is the right hand operand of the remainder function, and then the -1 is the answer we got. Okay, so that's going to be 4. So now let's have a look at the other one. So now these ones are the ones that are maybe problematic. So -9 divided by 5, and again that's going to give us -1. So the remainder is equal to -9 minus 5 times -1, right, which gives us -4. Sorry, I just want to... Okay, so that one is correct. And then the last one, -9 on -5. Very laggy. Is 1, and then the remainder is equal to minus 9, and then minus 5 times 1. So that ends up again being plus 5. So the overall answer is minus 4. So I think that one makes sense. Does that help at all?
Yeah, no, I did.
Okay, so yeah, thank you for that. That was a bit different, right? So that goes through the modulo and remainder operation. And we've talked about relational. I don't think we've used not equal, but that's an available relational operator. We haven't talked at all about shift operators, right? And the we should probably talk about those, right? There's 3 different sorts. There's logical shift, there's arithmetic shift, and there's rotations. Does everybody know what the difference between those two is? And since I've answered some questions already today, I'm going to see if somebody else can tell me. And I don't have is my bot not working this morning?
Kazuko bot is offline.
It is. That's no good. Don't you hate that? Oh, I know what the problem is. Maybe I don't. Oh, it's using the wrong... Don't you hate that? I restarted it this morning and for some reason it's decided... oh, I know what it is. Let me just fix that if you don't mind. Says it's listening now, so let's try that. No, it's not listening. Why don't you listen to me? The robot has learned to disobey. Yes, it's terrible. And now, of course, there are 2 copies of it running. There we go. Now I've got rid of everybody's comments too. Oh well, sorry about that. So let's get David. You know what the difference between logical, arithmetic, and rotations are?
Well, logically, it's like pointing to whatever's like in the space, left or right. But arithmetic is like doing like the math portion of it, correct?
Right.
Is that close?
Yeah, it's close. So, any more detail on what you mean by the math portion?
No, I can't.
Okay.
No, I don't have.
Let me pick on someone else. Quentin. Any thoughts? No, Quentin. You're on mute if that helps.
Yeah, I was on mute. Maybe shift left or right logically. It's like maybe shifting bits, but then like arithmetic rotate left and right would be maybe physically moving like a graphic. If you're working with graphics, maybe.
No, it's all about you've got a say an 8-bit register, and it's all about moving all the bits in an 8-bit register, but slightly differently in each case. Okay, let me pick on someone else. Matt, any thoughts?
Shift left and right probably moves the bits left or right.
Okay, that's certainly true. And what's the difference between a logical left shift and an arithmetic left shift?
All
right, shoot.
Is it something with the highest bit?
It is something with the highest bit.
If there's a 1,
well,
then it's a 1.
Yeah, if it's a 1, it stays a 1, and if it's a 0, it stays a 0. Exactly. So, thanks, Matt. The arithmetic ones, the aim with the arithmetic, there we go. The aim with the arithmetic ones is to preserve the sign bit. Okay. Whereas what happens with the logical ones is it zero fills. Right. So if you're shifting to the right and the sign bit comes in to the second most significant bit, then a 0 comes in if it's a logical shift, right? If it's an arithmetic shift right, then the value of the sign bit stays there. Whether it's a 0, it's a 0. If it's a 1, it's a 1. It stays there. But then it also copies itself into the second most significant bit. And then the rotations, funnily enough, all of the bits values stay. It's just the least significant bit comes up to the most significant bit on a shift right, or the most significant bit shifts out of its position and back into the least significant position on a shift left. Okay, the reason you do that is because one reason to do a shift left or a shift right is to multiply by 2 or divide by 2, right? And if the number that you have there is an assigned number, then you want to preserve the sign of that number. And doing an arithmetic shift left or right will multiply by 2 or divide by 2 and keep that sign. Whereas a logical shift left or a logical shift right, well, from a shift right, it'll zero fill. So if the sign bit, the most significant bit, was a 1, it'll fill with a 0. So all of a sudden the sign of your value will change, even if the magnitude has been multiplied or divided by 2. Okay, I hope that's okay. Let's just have another, oh, I wish it wouldn't do that. Let's have another little, we've talked about concatenation, we've talked about assignment, we've talked about delay modeling, we've talked about generics and constants, we've talked about generics and constants, we've talked about the after operator, we've talked about concurrency, not maybe explicitly, but we've talked about it as effectively this program, everything is happening at once, right? It's not, first of all, this assignment happens, then this assignment happens. It's like it's hardwired, so it's all happening at the same time. And there's conditional assignments, right? You can do a when on an assignment, so it's like it's pretty cool. You don't have to do an if statement, you can do a when statement. With a concurrent assignment, remember if you're doing assignments in a process block, the assignments are done step by step. But outside of a process block, everything's happening at once. So this example of a when statement allows you to do a conditional assignment outside of a process, which might be useful. And we talked about with select, we talked about structural design, we talked about component syntax, using a component inside inside an architecture. We sort of do that with all of our test benches anyway. We've talked about internal signals. I think we're pretty much done with most of these Vhdl notes. Let's just keep scrolling through. So I'm just going to quit OneNote and start it up again to get rid of that. I'm wondering if that's the problem. I usually have OneNote running all the time. Maybe I need to restart it every so often. Maybe that's why it gets finicky. We've talked about if-then statements. We've talked about case statements. We've talked about loops. Anything else? Attributes. We've talked about those. We had a long discussion about how that didn't quite seem to line up, but I think we eventually got to the bottom of it. And we've talked about test benches. Right, and the thing I want you to remember about test benches is, in general, you want to do, let's go with a blue colour. In general, you want to have tests in them. If you don't have an assert followed by reporting in the test bench, it's not really being a test. The whole point of a test bench, and let me just put that off. The whole point of a test bench is to allow you to automate your testing. That doesn't mean you don't do other sorts of testing. In fact, the best QA people that I've ever worked with are people who can basically break anything, but they don't do it necessarily with a programmatic approach. They do it with a bit of originality in there. And but once you find a problem, it's nice to be able to automate testing for that problem. And one thing I was a little disappointed with is I couldn't quite figure out how to automate the testing for those glitches that we saw in the 4-bit adder subtractor. Right, that was a little disappointing for me. It would be nice to be able to write a test for those. I might circle back and have a look at that later. Okay, so let's go back to our notes for today. We've got, I think everybody has or is about to finish Lab 5. I think everybody has possibly made a start on Lab 6. I think at least one group has finished Lab 6. So the aim is to get Lab 7 and Lab 8 out of the way this week and next week. And then we can talk about projects. I will talk about projects in a little bit. Before then, though, I think we all deserve a bit of a break. Does anybody have any questions about anything I've talked about this morning before we go to break? Okay, if not, I will start up a 10-minute break, and when we come back I want to do the explanation for Lab 8, and I want to talk about Lab 8 in a bit more detail. But let's grab our 10-minute timer from Google, and I will see you back here in about 10 minutes. Okay, slowly getting back. Sorry about that. Okay, I think we can kill the timer for now. I put that link in there and we don't need that for now, so let's move that over here. Okay, I left that in just as a reminder to if you need to change the run length in your model sim. So here's an explanation for Lab 8. I'm assuming Lab 7 needs no explanation. So Lab 8, the idea is that we want to count the score, the balls and strikes for a particular batter within baseball. And in baseball, the strike count goes up if the batter swings at all and misses, or hits and the ball goes foul, or if the batter doesn't swing but the ball goes through the strike zone as adjudicated by the umpire. And that's where you get the phrase 3 strikes and you're out. Once you get past 2 strikes and it's not a foul ball, then that 3rd strike means you're out. The other one is if the pitcher is not pitching accurately for whatever reason, the pitcher gets up to 3 ball counts against them. Once that 4th ball comes in, then that allows the batter to walk to first base and sometimes further, depending on the rules. I'm much more used to softball rules than baseball rules. In either case, once that count for strikes goes to 3, or the count for balls goes to 4, both counters get reset to 0. Okay, and the aim is to allow balls to be incremented by 1 using one of the push buttons, for strikes to be incremented by 1 using another one of the push buttons, preferably on the other end, so maybe the left hand end push button is the ball incrementer, and the right hand push button is the strike incrementer. And then the next button is a reset, because sometimes the batter actually hits the ball, and the reset to both counts to 0 has to happen when the new batter comes on strike. So that's reset. And then as a bonus, sometimes scorekeepers accidentally hit one of the other 3 buttons. And the idea with the undo button is that it allows the previous state of the system to be returned. Okay, and because that's a bit more complicated, I'm going to use that as a bonus for the lab. And the counts for both of the balls and the strikes have to be displayed on separate 7-segment digits on the board. Right, so here's the here's the circuit for the 7-segment digits, and I was intrigued by the translation into English from the Chinese to digital tube rather than digital display or what have you. But I checked with a Chinese friend of mine, or a couple of people who speak Chinese, and their assumption is that the translation tube is actually more perhaps like display. And my thinking about it was that maybe they were thinking about Nixie tubes, which is an old form of displaying numerals, but somebody pointed out that maybe it's just going back to the whole display thing with cathode ray tubes, the old, huge monitors and huge televisions that we used to have.
I like the Nixie tube idea.
Yeah, I do too. I've almost been tempted to get it. There's a kit you can get that builds a clock using Nixie tubes. But
Really?
it's been a bit expensive for me to.
Yeah, I was gonna say I've seen them on eBay, but they're usually like $100 to $200. So it's always like, no.
Yeah, they look cute. They do look very cute though. So.
They look amazing, and I feel like the noise they would make is also equally as amazing.
Yeah, that could be fun. So I had a question during the week, and I haven't answered it about how these things work. So one thing I thought we should try and do today is to actually answer how this works, right? And there's two things we need to understand. One of them is the select line, right? What these do is they select one of the digits, right? This top line is selecting. Now the thing I really dislike about this is saying dig 4, but it actually seems to go on to D1, right? Which seems like a mismatch in the numbering. But the idea is that if you select that line, then you're talking about that digit, right? And then these ones, even though this is a 7-segment display, there's actually an 8th one for the decimal point, right? So this is each segment. And what you have to do is you have to quickly select, if you want to just say we set the ball count here, right? You have to quickly select this digit and display its ball count, its counter number on here. And then you have to quickly select the other one, the right hand one, which is this digit, and then put its number up here. And you have to alternate between the two of them. And if you alternate between the two of them fast enough, or if you alternate between the two of them fast enough, then you should see, the human eye won't be able to tell the difference, but you should see a different number on each count if they're supposed to be different. Obviously, you'll see the same number if they're supposed to be the same.
That's called multiplexing, right?
That is effectively called multiplexing. Yeah, you're alternating between. And one of the things I always used to do is if you had this sort of a display and it's working like this, if you take your hand and you spread your fingers wide and you shake your hand like that and look through your fingers at the display, you should be able to see some of the segments turning on and off. You won't see all of them turning on and off because you'd have to synchronize your hand with the flickering of the display. But you should be able to see that that multiplexing happening. Okay, and one thing I forgot to look up is what the there we go. Here's a picture. Maybe, yeah. Let's grab that one. In fact, let's not do that. Let's copy the image. Right, so there's the A, B, C, D, E, F, G. And you can see they're labelled here A, B, C, D, E, F, G. And I'm just going to see if I can select that and make it a little bit smaller. Okay, so that should tell you what we have to do. So this is going to be a relatively complicated lab, and it's not so complicated from the counting side, because we could just make an integer value that goes from 0 to 3, or another one that goes from 0 to 2. 0 to 4 and 0 to 3 maybe. But the tricky part for this lab is going to be how we figure out how to display both scores at the same time. Well, we're not going to display them at exactly the same time, but it will look like they're being displayed at the same time because we alternate those select lines. Okay, any questions so far?
Are there while loops in VHDL?
You should have seen that in the loop section. Yes, I believe there are. Let's go back to the VHDL. Oops, wrong one. That one. I'm pretty sure. Right, there's a for loop and there is a while loop.
Cool.
Okay. So yeah, I'm pretty sure we looked at that. So before I do that, I just wanted to quickly show you my version of the LPM counter that I did, right? And right, so this is the one that I did in the lab, sorry, in the video. And in the video, I'd only selected, I don't know whether I can make that a bit bigger. Yeah, let's do that. Right, so in the video, I'd only pulled out the most significant bit as one of the outputs, but excuse me, later on I decided to pull out the next three most significant bits so it could have flashing lights at different repetition rates, right? And it's a bit hard to see. I wish I had a better way of even up here it's not very good, is it? it's a, but you should be able to see that the left-hand one there is going at about a second. The next one is going about twice a second. The next one's going about 4 times a second. And the frantic one at the end is going faster again. But I think that's kind of cool. And all I did was, let's put that there. All I did was pull out one of these counters, and I set it up as a modulo 50 million counter. And if you want to see how that works, have a look at it in the video that I put in the link, in the, I think it's the links chat in Discord. Okay, so the question as I said, the question I was asked was about how do these work, and the question specifically was, let's go back to our lecture 10 slides, there we go. So the question is, are these active, oops, come on, why did it do that? Went all the way to the top. The question I was asked was, are these active high or active low? And let's see if we can nut that out. And the same question over here. So let's see if we can nut that out. And I'm just going to do it by playing with the device. Okay, so let's make a new project, and I'm going to call this 7 segment display test, and just going to call it 7 segment display. And the top level design entity eq, I didn't want to do that. I need to do that. 7 segment display. Yes, I want to create it. It's an empty project. I don't have any files to add to it. I need to select my C8 device, I think it is. I need to make my simulation tool model sim altera and the format Vhdl, and then we're all good. Hopefully that'll fire up. And now let's make a new project or a new Vhdl file. And what am I going to do? What I'm going to do is, this is just a test of the 7 segment display. It's not actually going to do quite what we want. So what I want to do is I want to think about taking the using the 4 push button switches on the board and only lighting up one of the 7 segment displays when one of those push button switches is is pressed down, right? So I'm going to call that a std logic vector 3 down to 0, and I probably should have called that an input. And I might need to put a semicolon there. And then my architecture and I think that's all I need to do, and it's my 7-segment display. So that all looks pretty good. Now let's just see if that compiles, just to check that I've got my syntax right. No, I haven't. Oh, it's because I haven't pulled in the IEEE libraries. It's just I've forgotten the let's go with lab 7. Hopefully that'll compile. Thinking about it. Entity 7-segment display contains only dangling pins, but that's okay. We haven't actually done anything with it yet, right? So so that's the inputs, and then the outputs. What outputs do we need? Well, we need an output for each of the digits, right? So no, I think that's probably needs to be a comma rather than a semicolon. And then I need the actual digit output, which is going to be 7 down to 0. Remember, there are 8. Let's not call it. Let's call that selected digits, just to make it a bit different from digit. And let's call this one digit displayed. Okay, let's just compile that. Now let's think about what we want it to do. Right? If all we're interested in is turning on one of the digits, and looks like I should have had a semicolon there. Maybe a semicolon there. If all we're interested in is just turning on one of the digits, then maybe all we need to do right is to do that. Oops, wrong way around. We want that one to go there, and then we want the switches, which are the inputs, to go to the outputs. Let's try that again. Okay, so we're just connecting, all that's doing is it's just wiring up the switches inputs to the selected digits output, and we're done. That way I can just press one of the buttons and it should display something. But at the moment it's not going to display anything, or it might not display anything. In fact, let's check it out. Before we check it out though, on the board, I actually need to do something with the pin planner, right? Because we've got all these inputs and outputs, and I really do need to make something sensible happen there. So let me see if I can make something sensible happen. Right, and I'm going back to our GitHub repository for all the files that I've put together here, and 133, 135, 136 and 137 are the digit selects. 133, 135. So the selected digits, 133 is the lowest one, so let's go pin 133 there. Oops, I should have put an underscore there, I thought I had, but and then pin 135, and then pin 136, and then pin 137. Okay, so that's those, and then the segments are a little bit jumbled. Segment 0 is 128. So pin 128. 121 is the next one. It's a bit odd. $125. 29, 132. $26, 24, 27. Okay, and then my inputs are 88, 89, 90 and 91. $88, 89, 90 and pin 91. 88, 89, 90, 91. Okay, so now I've done my connection between the port statement in the entity for my top level entity and the pins that I'm going to be using. So that should work. And now I need to recompile it again just to get everything. I need to do the place and route, that second operation there in the in quarters. You will maybe have noticed when I switched back to here after doing the pin placement or pin selection that line was yellowed out because the pin selections had changed and it won't be able to. The previous routing had been nullified or not set up properly because I changed that. Okay, so there's that. And let's open the programmer. We've got our USB blaster and it's our appropriate device. Okay, so now let's have a look at what's happening. Okay, so I've got my device here. Right, and if I press that button, so they're going in the opposite direction. I'm pressing the right hand button, but the left hand digit is displaying. And here I'm pressing the second right hand and the second left hand one is displaying. So I probably want to swap around the orders there of the buttons that I'm using compared with the displays. But what you might remember from one of the other labs is that those buttons are active low, right? So it looks to me like the answer to our question is where's it gone? The answer to our question on this side, and let's go with green, is these are active low, so they only select when one of those inputs goes low. Sorry, I just wanted to check pushing multiple buttons, and pushing multiple buttons also does the appropriate thing, the appropriate numbers show up. So remember, all I've done is connected the switches up to the digit select lines. Right? That I haven't done anything about the other values. And when I do that select, that active low select, by pressing one of the buttons, all of the segments in the display, including the decimal point, light up. So I suspect that also means that we have an active low on that side as well. Okay, so let's see if we can't figure out. I want to put a I don't know. Let's just try and put a 0, right? And for it to get a 0 on this display, the only we don't want G, and we don't want the decimal point lined up, right? But we want A, B, C, D, E, and F. So let's see if we can set that up. And So what does that mean here? So no G. G is DP5. That's interesting. DP5. Is that segment 5? I don't know. We might have to do a bit of digging here. Right? Oh, there we go. There's the segments there, right? So DP5 is G. DP5 comes here, and that's segment 6. And let's have a look at what segment 6 was. Right, so that's the second most significant bit, 124. So we need to do something like this. Let's take our digit displayed, and let's see if we can figure out what it's supposed to be. So we don't want segment 6. And what else don't we want? We don't want the decimal point, which is DP3. DP3 is segment 7. Okay, so we don't want the top 2 lines to be set. So remember, this is active low. So I believe that means if we output 1 1 and then 6 zeros to the digits displayed output, that should display a on the selected digit. So let's see if we can do that. Okay, let's finish that compilation. Looks like it's pretty happy. We should get that happening. We're done. Okay, so let's open the programmer and program the board. And funnily enough, I don't know whether you can see this. Let's pull that up. Right, and now I don't have the decimal points lighting up, but I do have a 0 there. Right, so that is doing the right thing. I didn't change the selection, so let's go back and change the reverse the pin selections for the switches in our pin planner, just so that I get them to line up a bit better. So where's the pin planner? The pin planner is there, I think. And I think I want to swap, unfortunately that's 91, so I'm going to take that one away. And I'm going to change that to 91. And I'm going to change this one to pin 88. And I'm going to delete that one, that's pin 90. I'm going to change that one to pin 90. The reason I'm doing it that way is because it won't let me assign the same location to 2 different switches. it'll give me an error and won't let me do that. So there we go, there's our pin planner. Let's just redo the compilation and check to see that that's done the right thing.
You have to change the filter as well.
Change the filter.
When you go back to that screen.
Which screen? Sorry?
Oh, where you were changing the pin.
What do you mean by filter?
There was another line in there, and it had the old pin numbers you had. I can't see it anymore. Like you changed pin 88 on the left side, but like a couple rows over to the right, it was still
Oh,
like
yeah. No, that gets updated once you update it, right? So the filter location, that's just automatically assigned. It's fitter location, I think. Looks like it might be filter, but yeah, that just gets updated once the compilation happens, I believe. Okay.
All right.
And I think that's done again. Let's just check that it has. Maybe not. Yeah, that's better. So let me show you. I'll get the right. So now the button that I'm pressing lines up with the digit that I'm selecting. Okay, so what else do we need to do? Well, one thing I think we need to figure out is we at least need to figure out how to display a, so that displays a 0. We also need to figure out how to display a 1 and a 2 and a 3. Okay, so let's see if we can figure out how to display those. And what's the best way to do that? Let's go back here. So a 1 is probably, we just need only B and C. Right, so we just need those two. They're done. A 2 means we need A, B, G, E, D. A, B, G, E, D. And a 3 means we need A, B, C, D, G. A, B, C, D, G. A, B, G, E, D for 2 and A, B, C, D, G for 3. Okay, let's see what that tells us over here. So for 1 we need B and C, we need DP7 and DP4. DP7 is segment 1 and DP4 is segment 2. Right, and what does that mean? Segment 4 and segment 2. Right, so it's segment 4 and segment 2. Oh, we probably don't need to look that up there, do we? We can probably just figure it out. Hold it, what do they say? Segment 1 and segment 2. Segment 1 and segment 2. So I just need to select those two, and everything else I need to deselect. right? The previous one, it was just those two. So we just needed to unselect those two, but now we need to select those two. So B and C. So 7 and 4. 7 is 1. 4 is 2. So that, I think, means, let's just write it out. So we've got 7, 6, 5, 4, 3, 2, 1, 0. And we want segment to select segment 1. So we need a 0 there. And we need to select segment 2. So we need a 0 there. So I think that means, remember again, this is all active low. So those two are the active ones. And that's going to be the second least significant bit and the third least significant bit zeros, and everybody else ones. So let's try that. Just going to comment that line out. And so what we need here something like that. So that should display a 1.
So how did the first one display 0? I took it as it should be all zeros except bit 3 and 2 as 1, because it's the opposite, isn't it?
Right, so that's what this one did, right? So let's go back to 0. We want to turn off the G, right? Because we don't want that crossbar. We don't want that thing to happen, and we don't want that one. So we want to turn off the G and turn off the decimal point. To turn off the decimal point, that's DP3, which is segment 7. And to turn off the G, that is, well, it's hidden there, but it's DP5, and that's segment 6. Right, so we need to turn those two.
Which were 1s, weren't they? And the rest were zeros?
That's correct. And remember, that's why we went through the it's not going to let me go across, but that's why we talked about both sets of inputs are active low, right? An active low input means that when you give it a 0, that is a logic 1, and when you give it a 1, that's a logic 0, right? Normal logic is active high. That means the non-zero voltage is logic 1, and the 0 value is false, or logic 0. But when things are active low, it's the other way around, right? Active means true. So if it's active low, that means the low value is a true value and the high value is a false value. Does that make sense?
Yeah.
Yeah. So that's the 1. Let's see if we can do 2. So 2 is A, B, so we need to keep B and C again. And so this line is 1, we need to keep B and C, but we also need to put segment A, which is DP11, which is segment 0. So we also need to put a a 0 there. We need to keep those two on. Is that right? No, we don't want C. Sorry. We don't want C. Let me start again. So we do want A, which is segment 11, which is segment 0. We do want B, which is DP7, which is segment 1, so we do want a B. We don't want C, so C is DP4. DP4 is segment 2, so we want to keep that one off. So logic active low means that's a 1. We want G, excuse me, G is DP5. DP5 is segment 6, so we want a 0 there. E is DP1. DP1 is segment 4, so we want a 0 there. And D, it's the last one we were looking at in that list, is DP2, which is segment 3. And then the other two we don't, so it's 1 0 1 0 0 1 0 0 1 0 1 0 0 1 0 0. So I'm just going to eek. What was that again? 1 0 1 0. So it's 1 0 1 0 0 1 0 0, and that's supposed to be a 2. And then for 3, we want the same, except we want to turn off E and turn on C. Right? So E and C need to be swapped. So E is DP1, which is segment 4. So segment 4 is there, so that one needs to be a 1. What did I say? It's E. So E and C. C is DP4. I just said that, did I? That's segment 2. So segment 2 needs to be hold it. I've confused myself. So we need to turn on C and turn off E. So let's have a look at C. C is DP4, that's segment 2. So that's that one there. So I need to have a 0 there. And then I want to change E, and that's DP1, which is segment 4, and I changed E. And everything else, so those two flip over, and everything else is the same. So 1 0 1 0 0 0. Okay, so it's 1 0 1 1, and then all zeros for our 3. Oops. So let's see if we can do that. For some reason, it doesn't like me scrolling. So let's just quit it and go back to it. Oh, I see what I'm doing wrong. Sorry, it's just fat fingers more than anything else. So what was that number again? It was 1011. So this is for displaying a 3. And it's 1011 and then all zeros. Okay, so what I'm going to try and do is, let's just check the 1 first and see that we can see that that works. See that I've selected the right connections. Okay, nearly there. So let's push that to the board and let's get our handy cam up. Right, so now we get 1s displayed. And then let's, maybe I shouldn't point the camera at the screen. That might...
It's also covered up by the... Never mind.
Yeah, I just... it's kind of funky. I don't know why it's decided to go into La La Land. It's not actually... maybe just I have to kill that one. And then we can go back and try number 2. But I suspect we're okay. I don't know. Nobody called me out on any problems with it, so hopefully that's okay. We'll try number 2, and then we'll try the numeral 3 and see what happens. And we'll run that. And let me see if that... There we go. No camera found. That's no good. Aw, that's no good. There we go. It's better. Right, so now we're getting the numeral 2. Okay. And then last one, let's just, for completeness, check that we got the numeral 3 right. And check that that does the right thing. Okay, so now we can do that. Bring our camera back up. And we have 3s. Okay, so that sort of does the right thing. So does anybody have any questions about what I've been doing so far with the 7-segment display? The main tricky bit is the active low issue.
Is there a way to display 2 numbers at the same time?
Yeah. At the moment, I can display any number of numbers, provided it's the same number. Right?
Oh, but not different numbers yet, right?
Right. So what I was going to do is I was going to have a break, and then when we come back, what I thought we might do is figure out how to display 0 on the right-hand display, 1 on the second right-hand display, 2 on the second left-hand display, and 3 on the leftmost display. Okay, and when we push the button, so that to do what you suggest and have a different number on each display. But that's a little trickier, and I want to think it through before we actually do it. And I want to have a bit of a break before we do it. Any other questions? Okay, so let's again have a 10-minute break, and I will come back and we'll look at that. We'll look at that problem, and then I might give some quick remarks about the midterm. But let's take a break first. Okay. Any questions come to mind during the break? So what we have to do is do something a little clever, right? If we want to display a different numeral on each of these 7-segment displays, we need to select one of them and then tell it what digit to display, then select another one, deselect the previous one, and change what segments are being illuminated. So on this side of things, we need effectively a what do you call it? A round robin selection. All right, we need to select one, select the other, select the next one, select the next one. Just one at a time, not all of them or randomly selected. So that means we need to disconnect this connection, right? At the moment we're going straight from switches to the selected digits. Okay, anybody got any ideas how we might achieve what I just suggested? Now let's play bingo again. So Mohammed, do you have any suggestions as to how we might achieve it? We don't have to fix the whole thing. Let's just first of all go through and select one digit at a time. Any thoughts on how we might do that? So, Mohammed, you're on mute. No? Okay, let me try someone else. Jordan. Any thoughts?
I'm not really 100% sure how this syntax here works yet.
Okay, but but forget about the syntax. Any idea about how we might select one line at a time?
Nah, I don't know.
Don't know? Okay. So let me try somewhat else, and then I'll. Kyle Fields. Any thoughts? No, nothing from Kyle either. Okay. So at the moment, right, we're just passing all 4 switches to all 4 selected digits. So one thing we can do is we can pull out that connection, right? And maybe using something like what we talked about earlier today, using that modulo operation, right? If we do a modulo, if we have a counter and we do a modulo 4 operation, then what we should see is we should be selecting one of the switches at a time. Okay, so the first thing that's telling me is that we need another input, right? We need a clock input. Right, so we need a clock input. And the next thing it's telling me is, rather than doing that, we need to figure out we need a process looking at the clock what else do we need? Well, we need a counter variable, right? And so let's think about having a signal, which is our counter, and our counter is an integer, and it starts at 0. And then what do we do? Then we have a, well, maybe we need another one as well, called selected digit, which I'm just going to also make an integer. Probably doesn't need to be an integer. I'm going to set it to 0. And I'm going to say in here, selected digit equals counter mod 4. And now what do I need to do? Well, now I'm wondering if I can do something like this. I can say selected digits I'm going to turn them all off. And then one of them I'm going to turn on. And let's see if that compiles. So now I've broken the connection between the switches and the selected digit. Oh, I should know better than that, shouldn't I? Assignment is less than or equal to in Vhdl. Near text I'm wondering what I did wrong there. Any thoughts, anybody?
Do you think maybe the brackets is not correct?
Yeah, that's what I'm wondering. I'm wondering if the square bracket is wrong. Maybe I got that wrong. You could just suck it and see, but I'd rather know exactly. I'm sorry, I'm just Googling on the other page. Yeah, I got that wrong. It's not square brackets. Let's try that. My problem at the moment is that I am playing with VHDL, C#, and Python, and it all blurs into one sometimes. So, okay, so let's push that to the board and see if it does anything. I suspect it. Ooh. It does something. Let me pull up the camera. Right, it's lighting up the rightmost segment with a 3, but it doesn't do anything now when I do that. So I suspect we're going to have to do something else inside here. And I suspect it's going to be we need to have a rising edge or a falling edge to act on the clock then. Right, or the other thing that's happening is we haven't changed our counter at all. Actually, let's before we put the if statement in, inside here, let's go counter is counter +1. And let's see what that does. Hopefully that'll let us go through all of the digits rather than just sitting on the 0th digit. Okay, let's see what happens there. Okay, and now nothing's happening. Where's my camera? There's my camera. Right? None of the LEDs are on, and there's nothing happens when I press the buttons. So let's try and understand what's happening there. So I'm thinking now the problem is that we never get out of this process. So the selected digits, the selections never happen. So now I think we need to have that rising edge check. Let's see if that does anything. Okay, we'll run that. And now, lo and behold, we have 3s on all of them. Okay? No, remember we haven't actually done anything with these. So we need to do something with the switches now. Well, so one thing we could do is do a case statement. Okay? So down here, what I'm going to do, so we were displaying a 3 unconditionally, but now let's do a case statement. And we're going to do the case statement based on selected digit. Okay, and then we say when 0, then we need to do something like that. Let's try that again. So 1, 2, 3, and then digits displayed and then let's do a default, and we'll just turn everything off. And let's see if that compiles. Haven't used a case statement for a while, so I'm just checking quickly on Google that that's the right syntax. Ooh. Apparently not. Case selected digit is... Oh, do I need to do a case statement inside the... Yes, I need to do the case statement inside the process. I think that's the problem. Let's see if that works. Does everybody understand what's supposed to be happening with that? Both within the process, right? The process is counting, and it's not. It's just counting up all the way, and it's probably going to be a 32-bit integer, and it's then finding a modulo 4 version of that 32-bit integer, so we can select one of our 4 digits on the 7-segment display, and then just for simplicity, I'm selecting, I'm displaying 0 when that modulo 4 number is 0. I'm displaying 1, I think, when that modulo 4 number is 1, etc. So that seemed to work, and let's run it on the board. And I think we have a problem. Right, it's not quite clear, but it looks like a 3 there, but it's not quite that clear when you actually look at the displays directly here, because it looks like they're all of the digits are being displayed on all of the displays, right? But really quickly. So we're not selecting a different display. I would have thought that should deselect everything. Oh, so I'm wondering whether we also need to protect that with the rising edge. Protect the case statement. So the case statement shouldn't happen unless there's a rising edge, and it only happens that one time. Let's see if that fixes it. That's one of the issues with digital logic, designing asynchronous digital logic that works without a clock, is generally a lot harder to do than working with a clock. The reason why you might want to work without a clock is sometimes you can get better performance. And no, that didn't help. We've still got the same issue. And my camera program's decided to die, so let's restart it. Right, and I'm still getting the same, not quite 3. It's displaying, well, I think it's displaying 0, 1, 2, and 3. I think the top left segment is the dimmest, and that's the one that's only lit up when we're displaying a 0. And then the bottom left segment is the next dimmest, and that's when we're displaying a 0 and a 2, I think. And then the right 2 segments are the most. Okay, so let's try and figure out what happened. Oh. Any ideas on what you think's happening? I think it's obviously got something to do with the timing. So let's think about let's do this. Right, so now I'm pulling out setting the digit displayed and only changing the digit displayed when the selected digit changes. I'm a little confused. I thought that would work, but let's see if that helps at all. Right, remember the process sensitivity list, the thing in the parentheses after the keyword process, is going to only invoke the process if that thing changes. And oh, I forgot to put in a semicolon. So I've been actually I also been programming in Java recently. So the thing with all of those other languages though is that their IDEs, their integrated development environments, often tell me that there's an error before I have to do any compilation or running. So it's much easier to find. Whereas Quartus as an IDE is a little bit on the older side.
Yeah, Quartus is very interesting.
That's one word for it, yeah.
It's very minimalistic.
No, and that didn't fix it either. So what's happening is all of the digits are getting all of the numerals. And what I thought would happen is it should select each digit in turn, turn that digit on, and then only display the numeral that we're after. Don't think it's the case, but let's just try let's just check that it is actually changing. It didn't like me for some reason. What didn't it like? Is used for not synthesizable. Okay, so I can't actually do that on a. I can't use the event keyword on an integer. Fair enough. So I'm a little perplexed as to why it's not doing what I expect. Let's just using the word display. Let's call this select numeral, and let's change this digit displayed to numeral displayed. just wondering whether I need to blank out the numeral displayed. Let's see if that compiles. Ooh. I did something wrong there. Oh, because I've got dough. I can't do that assignment in two separate places because it's trying to assign two different values to the same hardware output numeral displayed. So I can't do that. So that wasn't the problem. Let's just, while I'm thinking about it, let's just recompile it. So on a clock event, a rising edge, we increment the counter, we find the selected digit, we deselect all the digits, and then we select one of the digits. Okay then. Now it's not actually displaying anything. No, it's not displaying anything now. Well, it's different. I'm wondering whether that means... Let's just comment out this case statement and see what happens. And let's just try and... Actually, let's try and display a 2. That's the usual roadies test, isn't it? 2, 2, 2. And let's see if all of the digits show a 2. I'm a little... I have this funny feeling I've forgotten something. You know what I think I've forgotten? Any guesses?
Your pinouts?
Well, look at that. Because I changed the name, I haven't got any. my numeral displayed is no longer connected. So I'm going to have to go back and put in all of those numerals. But the thing I was actually thinking about is I actually don't have a clock coming in. So let's actually put the clock in, right? The clock is pin 23. So that was the problem I thought I had. But now I've got these other problems as well, right? So digit displayed 7 is pin 127. And I'm just going to take a screenshot of that so I know the order that I want to put them in. And I'll just open that up on my other screen. Oh, I'm sorry, I should have been a little bit more awake to that problem. Let's just move that over to my other screen so I can edit this here. And I'm just gonna, I don't know if I can delete those. Yeah, I want to delete those assignments. Okay, and now pin 7 is pin 127, and then pin 6 is pin 124, and then pin 5 is pin 126, pin 132, pin 129, pin 125, pin 121, and pin 128. Okay, so now we have some sensible assignments. We actually have the clock coming in, which we didn't have before. That was part of the reason why it wasn't working. But let's just do that recompilation so we get all the right pins, we get the clock, and we're not going to, let's just see if we can show that the selected numeral is a 2 on all of the 7-segment displays. I'm a little worried that there are 15 warnings there. We should probably go back and have a look at some of those warnings. I think some of them are to do with selected digit because it's changing within the process and the selected digit isn't in the sensitivity list. But we should just check that that's the case. Yay! So where's my camera gone? There's my camera, and now we actually have all of those 2's showing, and that's doing the right thing. And now let's recompile and see if our I think I can toggle comments. No, it doesn't let me if I didn't toggle it to start with. Oh well. Okay, let's see what happens there. Okay, I think that's finished compiling. Let's open the programmer, program it, and we've still got the same problem. Right, we've still got all of the digits showing all of the numerals at the same time. So, I don't know. I don't know what I'm doing wrong there. Just showing 2 worked, but showing a different numeral on selected digit let's just try this. Now that we are actually changing the selected digit, I'm just going to remove or at least comment out that process. It's that separate process. I don't think it's going to have any material effect, but it may do given that now we are actually using the clock, whereas before when it wasn't working we weren't using the clock at all. Not quite sure why the things were working at all. Nope, same problem. Okay, I'm going to have to take this offline and figure out what we're doing wrong.
Since you're working with a clock, is it cycling through the numbers really fast? What if you set like a weight for each one? Will that do anything?
Oh, so maybe
Or
just
that type of clock.
maybe just slow it down. Yeah, maybe we could try that. Maybe it's trying to do it too quickly. But I don't know. Let's 100 nanoseconds. You reckon that's fast enough or long enough? Let's make it 10 milliseconds. Right, so that'll be that might be a little slow, but maybe it'll show us something. That's a good question, good suggestion. Thank you. So let's figure out why. Because the internal clock is a 50 megahertz clock. Oops. Didn't like something there. Wait statement must contain condition clause with until keyword. Process cannot contain both a sensitivity list and a wait statement. That's the problem. Well, let's just I do want to trigger it on the clock. So let's, instead of doing that, let's just do a delayed assignment. See if that helps. Don't know whether I'm using the right syntax there, but otherwise I'd have to take the clock out of the process sensitivity list and then I'm not sure I'd be able to actually trigger on the rising edge. No, that doesn't seem to help either. Let me just show you so you can see I'm not lying. Right, we've still got, sort of looks like a 3, but it's not not really clear because I think it's putting in all 4 digits that we're trying to display at once. While we're here, let's just check those warnings. Design contains 4 input pins that do not drive logic. Well, we're not using the switches. Some pins have incomplete I/O assignments. Refer to the so I think we're actually got the inputs connected up, we're just not using them. I think it's got something to do with the assignments within the process not happening until after we exit the process. And I'm not quite sure why that would be.
Do you maybe need to clean the project?
Oh, that's also not a bad thing. It's probably not an issue, but let's do a complete clean and then do a rebuild and see what that works. Always a good suggestion if you're running up against something that doesn't look like it's sensible. So let's wait for that. The other thing I'm thinking maybe I have to do is to have a separate numeral displayed for every numeral. And maybe I need to do that. No, it's still doing its same old thing. Right, they all look like zeros. Sorry, will look like sort of half-baked 3s. So let's, let's do this. Let's make another signal. And let's make it a 7-segment. Right, so that's the number to display. And then outside of all of our processes, we set our number to display to be the numeral displayed. Okay, so that's now hardwired. I'm going to take out those delays just because changing lots of things at once makes it hard to figure out. I'm pretty sure we decided that after 10 nanosecond delay didn't change anything.
When are you selecting the display you want?
When am I selecting?
So like, is it supposed to show through each of them? Each of the displays? Or are you selecting a specific digit? Not digit, but like the segment.
Okay, so this is the 8 bits that determines the numeral I'm going to display on one of the digits, and then this is telling me which digits to make that display on. So initially I set all of them to 1, which means it's active low, so that means they're all off. And then for a particular digit, I set that bit to be 0, active low, meaning I'm selecting that specific digit. Does that make sense?
Yes.
So that means I'm selecting only one of the digits that I'm in the display to change, and I now, instead of setting the output within the process, I'm hard coding the output to this signal number to display. Now, I don't know whether that's going to compile, but let's see if that compiles. If this doesn't work, I'm going to take it offline and I'll figure it out, and I'll let you know next time around. No, it's still doing precisely the same thing that it's always done. Let's just have a look at the warnings. The warnings look okay. Numeral displayed 7 is stuck at VCC, and that sort of makes sense because I don't ever change it from anything other than a 1. Ooh. whereas I think it's possible for all the others to change. Oh, that one doesn't change either, so, well. Oh, it might have, it does change from that. It does change there, so that's okay. It's just that first one that doesn't change. Okay, like I said, let's leave it there. I will get to the bottom of this, and it'll probably come to me about 5 minutes after we break. So that just happens. What I thought I would do though is quickly, very quickly, go through the midterm. If I can figure out where the midterm got to, there it is there. Okay, so most people understood what a flip-flop excitation table is. It's basically a thing that tells you, given the current state of the flip-flop and the next state of the flip-flop, what inputs are needed on the flip-flop in order to make the change. And a flip-flop's a 1-bit device, so you have a 0 to 0 transition, a 0 to 1 transition, a 1 to 0 transition, or a 1 to 1 transition. The specific excitation table for a JK flip-flop, I needed a 0 and an X, a 1 and an X and a 1, and an X and a 0. And then my follow-up question for everybody was, how do you set up a JK flip-flop? Right, let me just put that excitation table up. In fact, let me just put that into so I can draw properly. Okay, so for like I said, let me make the transitions are these transitions, right? And for a JK flip-flop, you want 0 and don't care, 1 and don't care and 1, don't care and 0. And my follow-up question was to see whether you understood what this table was saying, right? And my follow-up question was, how do you select the inputs J and K to toggle the flip-flop? And toggling means 0 going to 1, going to 0, going to 1, etc. So to figure that out, we first of all look at the first transition, 0 to 1, so we need a 1 and an X. And then we look at the next transition, we need a 1 going to a 0, 1 going to 0, so we need an X and a 1. If you add those two up, we need a 1 and a 1, right? We need J equals 1 and K equals 1. The present states and next states from the table, there was some confusion about people thought capital A was the present state and capital B was the next state, but no, each of these was potentially part of the present state. So the present state next state table looks partially like A, B, C, D, C, D, E, F, E, F, G, H, G, H, J, K, M, N, sorry, J, K, M, N, M, N, P, Q, P, Q, R, S, R, S, A, B. Right, and then it goes back to the top again. So that was what I was looking for there. Explain how you would use those tables. Well, one explanation would be that you would augment that table, that present state, next state table, with all of the JK columns that you needed in order to get that, and then fill in, okay, how do I go from A to C? That's my maybe my J1 bit, and then look up the JK flip-flop table to look at that transition. You then take a column that you've filled in and put it into a K-map and simplify. How many flip-flops? Well, it was a trick question, and the trick is that we're only seeing 2 bits, but there are 8 states. So that means that there's a hidden bit, because 8 states is 2 to the 3. So that means in order to count through 8 states, we need 3 bits. And I apologized, I think for 2 people, I made a mistake on the 1s and 0s that I gave you. And the 1s and 0s that I gave some people would have required 4 bits to do it. But that was above and beyond. So I hope I've fixed that issue with you. If I haven't, please come back to me and we can talk about it. So the Carnot map, it's a reordering of the truth table, and it lets you simplify the logic. And the example I asked everybody to look at, not the same example, but it was a very similar example, was something like that. A group of 4 and then another 2 bits. And the simplification happens by circling 1s, and then the issue is that the K-map is like a donut, right? This edge here connects up with this edge here, and this edge here connects up with this edge here. So it's like a toroid or a donut. And the thing that I was quite surprised at is a lot of people couldn't just go from that grouping to a simplification. And they were perfectly capable of doing the algebra to get the simplification. But for me, this graphical representation is much easier. And the way you look at it is you say, well, okay, for this group of 4, what changes? And if something changes, that means I don't care about it. So here, I don't care about B, and A is a 0, so I have an A bar. And on this axis, the thing that changes is the D, and C is 0, so that's a C bar, right? And that's the way to get a simplified version for this. Then it's a sum of product, so there's the product, there's the sum, and on this one, sorry, let's go here, so 0, 0, and 1, 0, so the thing that's changing is A, and the thing that doesn't change is B is 0, so it's a B bar. And then on this, it's the 1, 0 column, so that's a C D bar. I didn't do the same pattern for everybody. I gave the same grouping of 4 and the same pair-wise, but that's what I was after. I was after to be able to simplify. The explain how your design works. There were 2 possibilities, a more machine and a merely machine, right? So 0, 1, 2, up to n minus 1. One of them just makes a counter going between the number of states and puts some logic in there and presents the output that way. The other one forces the counter to go in whatever the numerical values is, and the way it does that is it takes the state information, puts it through some logic, and then feeds it back. This way of, the way I explained about how to do the design, this way is this variant here, right? But either way will serve. You can do the design either way. In fact, if you're doing the VHDL design, it's much easier to do the design this way than it is this way. So my main reason for asking the question is to see what your explanation was. If you're designing an entity, the inputs and outputs for this thing, then all you really need is a clock, A and B. You could put A and B together if you wanted. And then in the architecture, the explanation I would have given was just to have a modulo n counter with A and B set using a case statement, for example. But several people just did the design using JK flip-flops, and that was perfectly okay too. Like I said, either of these techniques can do. But one thing I'm hoping you get out of this course is you can be shackled a bit by thinking about digital logic just using flip-flops and gates, particularly if you have access to a VHDL way of doing things. And sometimes the VHDL way of doing things is much easier. For example, the adder-subtractor lab. It's much easier in the adder-subtractor lab to just add and subtract using plus and minus in VHDL than it is to have 4 full adders and connect up the logic to do the add subtract. Okay, that is about all I have. I'm going to get to the bottom of this, but I'll do this offline, and I'll do another short video to show what the problem was once I figure it out. Does anybody have any questions about the labs we have to do? I have been talking a lot. I'm happy to stay on the line and consult with any labs for the next, I don't know, half an hour or so. But if you don't want to do the lab now, or if you're not set up to do it, that's okay. I haven't talked about the project. I will make some more notes and release that fully next week. But I did talk briefly about it. I do want you to do something a bit more complicated, using either a protocol or using the VGA output. But using the VGA output might be a bit harder if you don't have a spare monitor and a VGA cable. Any questions? Okay, if there are no questions, thank you very much for your time today. I will get to the bottom of this display thing, and I'll show it to you. I'll upload it into the GitHub repository so you can see the full code. I haven't been doing that with my examples. I should have been doing it, so I will upload that. Okay, let's leave it there, at least from a display viewpoint. And but I'm happy to, like I said, hang around and help out with any lab questions. If there's more than a couple of people with labs, we might have to use the queuing mechanism. Right, the join queue and leave queue, but otherwise, have a good rest of your weekend.
Have a nice weekend, Professor, and happy Halloween.
Happy Halloween, everyone.
Happy Halloween.